In this section, we're going to talk about permutations, rearrangements. That's all that is. Permutations. Suppose you have the letters A, B, C. How many different ways can you rearrange it? Well, if A is first, then B and C have to follow it. So you can have A and then B, C, or you can have A and then C and then B. If B is first, then there's only two other letters left over, A and C. You can have A first and C second, or C first and A second, where B is always first. Or you can have C first. Well, if C is first, there are two letters left over, A and B. You can have, say, AB or BA. There are 6 different ways to permute these 3 letters, A, B, C. How I like to think about it is decisions. And whenever you say the word and, you multiply. You have 3 letters. And you want to put one in each of those positions. You want to put a letter here, a different letter here, and a different letter there. The first thing you need to ask yourself is, how many letters do you get to choose from first? The answer is clearly 3. You get to choose from 3 letters. And you chose a letter. Maybe you chose B. And then you choose another letter. And then you choose another letter. Well, there are 2 letters left over. You choose one of them. For argument's sake, A. And then you choose another letter. And then you choose from one letter. 3 times 2 times 1 is 6. There are 6 different permutations for the letters A, B, C. How many different permutations are there for the 4-letter word face? For the 4-letter word face, how many different permutations are there? Well, in my opinion, the easiest way of doing it is with the spaces. There are 4 letters. So the first choice you make, when it comes to putting down the first letter, you get to pick from 1 out of 4. You get to pick from 4. You picked one letter, whether it's F or A or C or E, you picked one letter. There are 3 left over. When it comes to picking the second letter, you get to choose from 3. Just like you get to choose your ice cream, vanilla, chocolate, or strawberry. And after you pick that second letter, there's 2 letters left over for the third position. You get to pick from 1 of 2 letters. And then you get to pick for the last letter. And there's only 1 left over to pick from. So the answer is there are 24 different permutations for the 4 letters F-A-C-E. F-A-C-E. In the last problem, we had 3 times 2 times 1. In this problem, we have 4 times 3 times 2 times 1. It seems that if you start with a number, you keep multiplying by the numbers before it until you get to 1. You start at an integer, and you keep multiplying by the numbers before it until you get 1. Leads us to think of some kind of notation. For example, 5 factorial, by definition, there's nothing to understand to definition. You never asked anyone, why do we call that a horse? And why is it called the horse? Because that's the definition of a horse. An animal with 4 legs that looks like this, that, and other characteristics, that's a horse. Why? Because somebody defined it that way. 5 factorial. You started this number, and you keep multiplying by the numbers before, the numbers before, the numbers before, until you get to 1. If I'm not mistaken, that's 120. 7 factorial. You start with 7. And you multiply by the numbers before. 6, 5, 4. Just count backwards. 7, 6, 5, 4, 3, 2, 1. Blast off. Okay, just stop at 1. That's what 7 factorial means. N factorial. Well, when it was 5 factorial, I started with 5. When it was 7 factorial, I started with 7. You know, why don't I do the same? I'll start with n. I multiply by 1 less, and then I multiply by 1 less. Eventually, I'll get down to 3 times 2 times 1. These 3 dots means there are possibly other numbers there. If n is 7, well, let me not say 7. If n is 10, you have 10 factorial, 9 factorial. Sorry. First of all, there's a typo here. It's n factorial equals n times n minus 1 times n minus 2, etc. Not n factorial. Sorry. If n is 10, 10 factorial is equal to 10 times 9. 10 minus 2 is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There are numbers in here. For example, if I was really going to write down 10 factorial or 100 factorial, I'm not going to write this. I'm not going to say 100 factorial is 100 times 99 times 98 times 97 times 96 times 95 until I get to 1. I just put 3 dots. It means and so on, all the way down to 3 times 2 times 1. You don't want to write this 3? Don't write this 3. All the way down to 2 times 1. Okay, it's up to you where you stop at or pick up at. I picked up at 3. That's what 100 factorial is. It's a very big number. The number of ways of permuting 5 distinct letters. The number of ways to permute 5 distinct letters or numbers or boxes, I don't care what they are, envelopes, light bulbs. The number of ways to permute 5 distinct letters is 5 factorial. If you have 5 different letters, R, Q, the Greek letter lambda, the Greek letter alpha, and S. The number, so you know, R, Q, lambda, alpha, S, that would be 1 permutation. And you know, Q, R, lambda, alpha, S would be our second ordering of these 5 letters. There are 5 decisions to make. Which letter do you put in the first, because there are 5 letters. Which letter do you put in the first position? Well, I get to pick from 5, and then you picked 1. So now there's 4 left. And then you get to pick from 4 for the next position. And then 3, and then 2, and then 1. Like I said, 5 factorial. The number of ways to permute 15 distinct letters is 15 factorial. It's going to be 15 factorial. The number of ways of permuting 22 different letters is 22 factorial. In general, the number of ways of permuting n distinct letters will be n factorial. The number of ways of permuting n distinct letters is n factorial. Maybe I should have brought it up a little bit earlier, but distinct means they're different. R and Q and lambda and alpha and S, they're all the same. Well, what if they're not the same? What if they're not the same? What if I have the letters A, B, A, C? Two of those letters are the same. So right now, let's call it A1 and A2. There are 4 letters. 4 factorial is 24. There are 24 different ways to write this. Unfortunately, we're going to do that. If you have A1 and B, you can have, we'll play games with these two. A1B and then CA2. That's A1 and then B. You can have A1 and then A2. B and C remain. I can have BC, or I can have CB. So I did A1 with B, A1 and then B, then I did A1 and then A2. Now I'm going to do A1 and C. So B and A2 are left over. I can have B and A2, or I can have A2 and then B. There are 6 of them. That's with A1 first. Well, why couldn't B be first? First, I'll do B and then A1. And then I'll do B and A2. And then I'll do B first and then C. But after doing B, let me write the letters down again since I drew on them so much. If I do B and A1, well then those 2 remain. I can have A2 first and then C, or I can have C and then A2 first. If I have B and A2, that leaves A1 and C remaining. Can have A1 and C, or C and A1. BC. If I use B and C first, then I have A1 and A2 left over. I can have A1, A2, or I can have A2, A1. That was where B first. Well, C can be first. You can have C with A1. You can have C with B a couple of times. You can have C with A2 a couple of times. If you have C with A1, A1, B, A2, C. If you have C and A1, B and A2 remain. You can have B and A2, A2 and B. If you have B and C first, then the last 2 have to be A1 and A2. You can have those 2 in that order, or you can have in that order. If you have C and A2 first and second, A1 and B remain. You can have A1 and B, or you can have B and A1. That group is where C is first. You had A, B, A1, B, C first. You can have A2 first. You can have A2 with A1 second. Or you can have A2 with B second. 2 different ways. You can have A2 with C being second. A2, and C. Let's look at that first one. First, let me erase this and write it down more clearly. Okay, the first two have A2, A1. That leaves B and C left over. You can have BC or CB. AB2, that leaves A1 and C left over. You can have it in that order, or you can have it in that order. The next one, I still don't like how it's written. A2 and C. So A1 and B are left over. You can have A1B or BA1. There are 24 of them, but I claim that half of them are repeated. For example, I don't see why we wouldn't have an A2B, A1C somewhere. A2B, yeah, oops. A2B, A1C, this one. See, there's really no subscripts on the A and the B, on the A1 and the A2. Those two words look the same. They both say A, B, A, C. This one gets removed. A1B, C, A2. A2B, C, A1. Here it is. This is ABCA. Just like that one is ABCA. Half of them are going to be removed. This one, A2, A1, BC. This is AABC, just like the one I just put the box around. A1, A2, CB. That's the same as this one. Exactly the same. Half of them are going to be knocked out. Why do we divide by 2? Just for the record, 2 factorial, that is 2 times 1, is 2. We can, for every one we write down, we can permute those 2 letters 2 ways. You can have A1 first and then A2, or A2 and then A1. That is, the number of permutations, will not be 4 factorial. So the question is, how many different ways can we arrange the letters A, B, A, C? And since there are 4 letters, I can write down, like I did, 24 orderings, but some of them are the same. There are the letter 2 times, 2 factorial. This is 4 times 3 times 2 for 4 factorial. I'm going to stop writing the 1. Multiplying by 1 doesn't do anything. Divided by 2. You can say the 2's cancel. You can say 2 goes into 4. Either way, you're going to get 12. Right. Now, let's up this a little bit. What if we have a 5-letter word, or 5 letters, but 3 of them are the same? Suppose you have A, B, A, C, A. That should be an A. Suppose you have these 5 letters. The question is, how many ways can you write down 5-letter words? And no, these words, you can't say, well, apica isn't a word. This is our own vocabulary. You can't say, well, what do you mean? If I write B-C-A-A-A, I know that's not a word. I'll look it up in a dictionary, and it's not there. Well, I don't mean it that way. We're making up our own vocabulary. We're only going to talk about 5-letter words, and they have to come from these 5 letters. See, the thing is that, if I temporarily think of those as different, say A1, A2, and A3. Well, one search word would be A1B, A2C, A3. But are there any other words that will look exactly like this? And the answer is yes. I can permute those 3 letters. I can say A2B, A1. Well, let me do it so I can even know the order. A1B, A3C, A2. Or, A2B, A1C, A3. Or A2B, AC, A3C, A1. Or A3B, A1C, A2. A3B, A2C, A1. These 6 words, look at that. They're exactly the same. Why are they the same? Because there really are no subscripts. There really are no subscripts. These are the 6 different ways to permute those 3 A's. But they give you back the same exact word. They give you back the same exact word. That is why we're having this situation. That is why we're having this problem. They give us back the same words 3 factorial times. No matter what 5-letter word I write down using those letters. If I write C, and then A1, A2, B, A3, C, A1, A2, B, A3, that's a 5-letter word using the 5 letters on top. Well, again, I can permute those 3 A's 6 different ways. And we can't count it 6 times. We can't count each one 6 times. The question is, how many distinct 6-letter words can we write? And the answer is going to be, there are 5 letters. There are 5 letters, so it's 5 factorial. One of the letters comes up 3 times. So it's going to be 5 times 4 times 3 times 2. That's 5 factorial. And 3 factorial is 3 times 2. Again, I'm going to stop writing down times 1. It doesn't do anything. This cancels out, and you get 20. There are 20 different ways of writing this. If you like, you can say, well, let me write it down here. A1B, A2C, A3. How many different ways we can permute them? Well, there's 5 letters. A happened to be the first. We don't even need the subscripts. We don't even need the subscripts. We don't even need the subscripts. A, B, A, C, A. Okay, so we have A, B, A, C, A. First I see A. There are 3 of them. So you write 3 factorial in the bottom. B, there's only 1 of them. You want to write 1 factorial, you can. Let's write this down again. 1 factorial is just 1. So that's not really going to, dividing by 1 in the bottom, the rule for dividing by 1 is don't bother. Dividing by 1 doesn't do anything. So again, you have the letters A, B, A, C, A. There are 5 letters. That prompts you to put 5 factorial. A, B, A, C, A. There are 3 A's. You can put 3 factorial. There's 1 B, if you like, you can put 1 factorial. There's 1 C, you can put 1 factorial if you like. Dividing by 1s won't do anything. So you're still back to 5 factorial over 3 factorial. And as we showed above, that's 20. Okay. One more problem. We use the word, or at least one more. We use the word mathematics. How many different permutations can you make from the word mathematics? Well, the first thing you want to know is how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you put 11 factorial in the top. Then you see M first. 1, there seems to be 2 M's. And you have to be correct on these. 2 factorial. There seems to be exactly 2 A's. 2 factorial. There is, believe it or not, 2 T's. Another 2 factorial. If I'm not mistaken, there's only 1 H, and I'm not going to write the 1 factorial down. There's 1 E and 1 I, C, and S. And here it is. In exam, I would just want you to leave the answer like that. Okay, this is the number of different permutations for the letters in the word mathematics. If you're going to make up words only using, so 2 rules. You can only use these 11 letters, and you have to use all of them. How many different looking words can you make using the words mathematics? And this is it. 2 factorial times 2 factorial times 2 factorial. You can't say 2 times 2 is 4 times 2 is 8, so it's 8 factorial. That's not true. Why? Because 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2, whereas this is 2. 2 times 1 is 2. This is 2, and this is 2. That's 8. 8 does not equal to 8 times all of this. Okay, it's not equal. You can't do things like that. 3 factorial times 5 factorial is not 15 factorial. It is not. Because this is not 3 and this is not 5. Do one more. Suppose you have these letters, A, Q, R, A, R, Q, another Q, or U, and R, and another Q. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I didn't miscount, there are 10 letters. How many 10-letter words can you make using those 10 letters? Well, if they were all different, it would be 10 factorial. But there are 2 A's. So you divide by 2 factorial. There are 1, 2, 3, 4 Q's. So you divide by 4 factorial. and there are 1, 2, 3 r's. So you divide by 3 factorial, and there is just 1 letter u. This is how many there are. Okay, you can do 10 on your calculator and hit the factorial button, and then division, and open up a bracket, because we're dividing by a lot. We're dividing by 2 factorial times 4 factorial times 3 factorial. And how you get the factorial on your calculator depends upon which calculator you're using. The next section we're going to cover will be combinations.